Hello everyone. This video is the first in a three-part series to demonstrate how to use the CyCon Life Cycle Assessment tool. In this video, we will be conducting a simple environmental life cycle assessment of a hypothetical public transit system. To start, let's examine our scenario. This map depicts a residential area where 100 inhabitants work in one of four locations indicated by their color. Each of the green diamonds represents a bus stop in the proposed transit system. Our goal in this life cycle assessment is to examine the CO2 emissions generated by a diesel bus traveling between each bus stop, and the emissions generated by the workers driving personal vehicles to work. For this scenario, there are a few key assumptions we need to go over. First are the key assumptions surrounding the cars driven by the workers. A car will emit 0.8 pounds of CO2 per mile that it drives, and the cars will drive their route 2 times a day for 260 days of the year. Next are the assumptions surrounding the diesel bus. The bus will emit 1.2 pounds of CO2 per mile that it drives, and the bus route takes 1 hour to complete. The bus will run for 10 hours a day, 260 days a year. Now let's go over how we will calculate the pounds of CO2 emitted per year by the workers' cars. First, we'll find the total sum of distance traveled by all workers in one trip, measured in miles. Then, we will multiply that by our estimate of 0.8 pounds of CO2 per mile traveled. Multiplying that by 2 trips per day and 260 days per year will give us the pounds of CO2 generated each year. This is the workflow for calculating the CO2 emissions of the bus, which is similar to the workflow for the cars. First, we calculate the length of the bus route measured in miles, multiply that by 1.2 pounds of CO2 per mile traveled, multiplied by 10 trips a day for 260 days per year, and we get the pounds of CO2 generated per year by the diesel bus. Next, we'll look at how to use the CyCon Life Cycle Assessment tool to perform these calculations. This here is the interface for the CyCon Life Cycle Assessment tool. The first thing you can do is enter in your project name as well as the goal and scope. The next step is establishing our life cycle inventory. To do this, we're going to select this button here that says Add Process, which presents us with two different ways of adding data into our lifecycle inventory. The first is to upload a CSV file from your local computer. To do this, select the paperclip next to Attach File, which will open a dialog box where you can select a file to upload. Once you upload the file, the data will appear over here in the right-hand side. Since we want to compare the emissions generated by the workers driving cars versus the emissions generated by a bus, we will want to add a second process and add data for that process. To do this, we'll select Add Process once again, and this time we're going to explore the second option to select and upload a dataset. To upload a dataset into the CyCon Lifecycle Assessment tool, we'll first go over here to Datasets, click Choose File, select the data set you want to upload. Once that file name appears right here, you'll click Upload, and the name should appear in this list down here. Now we can return to the LCA tool. Once we're here, we'll click Select Uploaded Dataset, and select the data that we want to use. And just like when we upload from our own computer, the data appears here on the right-hand side. Now that we have built our life cycle inventory, we can move on to our life cycle impact assessment. The first thing we'll do is rename our processes. Process 1 will be cars, pounds, CO2. And process 2 will be bus, pounds, CO2. Next, let's add the formulas that model our processes. We previously discussed our workflow, where a formula for modeling each of our processes was presented. To adapt those formulas for use in the CyCon LCA tool, we will use the syntax required by the SymPy Python module, which is a library that can parse mathematical expressions and apply them to a set of data. More information can be found by reading the SymPy documentation or by consulting the summary sheet linked here. To model the annual car emissions, we will use the following expression: sum of red plus sum of blue plus sum green plus sum of yellow. This represents the total distance all workers travel in one trip. Then we multiply it by 0.8 for our pounds of CO2 emitted per mile traveled, multiplied by 2 trips per day. We multiply that by 260 days per year. This next expression models the emissions from the bus. Sum bus, which is the length of the bus route, times 1.2 pounds of CO2 per mile traveled. Multiply that by the 10 trips that the bus takes around its route each day, and we multiply that by the 260 days of the working year. Once all the formulas have been written, we can finish our assessment by clicking Perform. Here in the Results and Interpretation section, we can see the results of our life cycle assessment. As we can see, the cars are emitting 48,268 pounds of CO2 each year, whereas the bus is emitting 26,298 pounds of CO2 each year. Thank you for watching. In the next video, we will be demonstrating a simple economic life cycle assessment using the same scenario.